Hello, this is Mrs. Berlinghoff, and this is Geometry, Chapter 11, Section 5, Circumference and Area of Circles. Once again, we're on this kind of low-tech method of presenting the lesson for those of you who are either absent or need a refresher on this. The pen, which I normally do the lessons with, still waiting for the repairs and for the replacements. So we're just going to use this video method until that arrives. So here we go, circumference and area of circles. I guess even though my first objective here is to define pi geometrically, which we will do here in a moment, I guess it should be said that we really need to define what is a circumference and an area of a circle. Of course, an area of a circle is easy. It's the region that's covered by the circle. Imagine, if you will, a round rug. The material that makes up the rug represents the area, or if you will, the region of the floor covered by the round rug is the area of a circle. The edge of the rug is the circumference. A circumference can also be described, think of a hula hoop. The circle itself, if you were to attach a tape measure and measure around a hula hoop, that's a circumference. Basically, it's like the perimeter of a circle. But we don't use the word perimeter because perimeter is used for polygons whose sides are line segments. But it's very similar to that concept. So here we go. First objective, define pi geometrically. There are other ways to define pi besides just as this. But what happened, a brief history here, thousands of years ago, literally before Christ, there were mathematical thinkers who realize that there's a relationship between the distance around a circle and the distance across the circle. For a long time, they recognized that the distance around a circle was approximately 3 times larger than the distance across it. Of course, the distance across a circle is called the diameter, and the distance around the circle is the circumference. It's very interesting that they noticed that relationship, and it led to, over hundreds of years and really thousands of years, it led to an understanding that every circle, if measured precisely, when you measure the circumference precisely, if you divide the circumference by the diameter, it always gives you the same number. And because that number is always the same, we gave it a name, pi, which was assigned sometime in the 1700s. Pi itself is an irrational number, meaning it's a decimal that never terminates and never repeats. So we approximate it. In most of our high school math classes, we can approximate pi to about 3.14. Occasionally, we'll carry it out to a few more decimal places, 3.1415. And of course, you can carry it out a lot further than that if you need to. But for the most part, in our high school math classes, when we're estimating circumference and area of circles, 3.14 is sufficient. And sometimes it's represented as 22/7. So, now that we know that this number pi exists, what it allows us to do is to find the circumference of a circle and the area of a circle with one simple, easy measurement. It's difficult to measure something that's round. So our second objective here is to use a formula to find the circumference of a circle instead of trying to measure around it. We measured in class. We had some round objects. We had a salt shaker, which was very small. We had a tin which was a lot larger. We also measured around a container of Clorox wipes, which was obviously a round container. And we used a tape measure to do that, but it's still hard to measure around something round and to measure it precisely, and especially hard to measure something round and two-dimensional, like a circle that you draw on the paper. Imagine trying to wrap your tape measure around that thing, right? That's very difficult. So the discovery of pi allows us, and the refinement of it, allows us to accurately measure a circumference without the difficulty. All we have to be able to measure is the diameter. If we can measure the diameter, which is of course just the distance across the circle through its center, which is just a line segment, anybody can measure that. If we can measure that line segment, we can calculate what the distance around the circle is using this formula right here. The circumference is equal to pi times the diameter, or, if you're given the radius, 2 times pi times r, because the radius is half the diameter. Knowing pi also allows us to use a formula to find its area. Instead of trying to break the circle into parts and figure out how many square units fit into a circle, we can simply measure its radius and plug it into this formula here, pi times the radius squared. And that will allow us to determine the region covered by any circle simply by measuring its radius, which is just merely a line segment, an easy measurement to make. So let's go ahead and apply these formulas, and some things to know. If you're not told, here's our examples here. Find the circumference and area for the following. Let's look at this example first. A circle with a radius of 4 inches. Notice here we're not told to substitute anything for pi. Therefore, we leave pi in the calculation. 2 times pi times r right here. And we leave pi in there. 8 pi inches. For the area, it'll be pi times the radius squared, which is 4 inches squared. And therefore, the area is 16 pi inches squared. We can predict that just by knowing what the radius is. That's actually pretty fascinating. Now, sometimes you'll be asked to use an estimate for pi, as shown here. You're to find the circumference and the area of a circle with a diameter of 10 centimeters, and you're supposed to use pi equaling 3.14. So we use the same formulas as before, only now we have a diameter. The diameter times pi is the circumference, and we're supposed to use 3.14 for pi, so we do, and we get 31.4 centimeters. And then using the formula, remember, if the diameter is 10 centimeters, then the radius is 5 centimeters. So to find the area of the circle, we use our radius squared, 25, times pi, which in this case we're told to use 3.14, and thus our answer, 78.5 centimeters squared. Remember, areas are always measured in square units. And that's the end of section 5 in chapter 11 for geometry.